Perspective Class 4 Video 1. In this video we're going to start talking about linear distortions. In particular we're going to talk about S-linear distortion. So what's the definition? The definition of S-linear distortion is it's the operation where you multiply every point on a figure by the scalar s. So s is some number which you have to specify. So S-linear distortion just means you have some figure, okay, like any figure you want, and you multiply every point on it, like you scale it by a factor of s, so it just gets bigger. This is not a very accurate example, but this is S-linear distortion. So technically the mathematical way of thinking about this is you imagine every point on your figure is like a vector, okay, where there's some origin, and then you just multiply. So if this is maybe a 2 linear distortion, then this vector goes to twice the vector. That's a 2 linear distortion. So let's look at a more concrete example. So in this example I'm going to consider the triangle given by the vertices 0, 1, -1, -1/2, and 1, -1/2. So it's the green triangle which I've already drawn. And all I want is for you to apply the following S-linear distortions. Okay, and I give you the numbers. So first of all, s equals 2. So all that means is like every point you treat as a vector, and then you apply a scalar factor by 2. So this point right here, the point 1, 0, when you do a 2 linear distortion, that gets mapped to the point 2, 0. Okay, this point right here, what is this point? This is the point 1, -1/2. Well, when you do the 2 linear distortion, this gets mapped to 2, -1. So 2, -1. And this point here gets mapped to -2, -1. Okay? And a special thing about S-linear distortions is they send lines to lines. So to work out the image of this triangle, it suffices just to know the image of each of the vertices. And I've just worked out the image of each of the vertices, so now I can just join them up with somewhat straight lines, like this. Okay, so this yellow triangle is the 2 linear distortion of the green triangle. And now you do the same thing for s equals 3. So s equals 3, I want to know where does this point go. That point there is the point 1, 0, and that's going to get sent to the point 3. Well, if I was to write this out, it would be 3 times 1, 0, which is just 3, 0, which is all the way up there. Okay, this point here is the point 1, -1/2, and that gets sent to the point 3 times 1, -1/2, which is 3, -3/2. So 3, -3/2 is there. And finally this point here gets sent to -3, -3/2. Let me erase this to make more room. And I know that all S-linear distortions, they send lines to lines, so now I just need to join up these points with a somewhat straight line, like that. Okay, and lastly, how about s equals -1? So I look at this point here. This point here is the point 1, 0, and that's going to get mapped to the point -1 times 1, 0, which is -1, 0, which is this point down here. This point here is the point 1, -1/2. That gets mapped to -1 times 1, -1/2, which is -1, 1/2, which is this point right here. And finally this point here gets mapped to this point here. So I just join up these lines like this. Okay, so the red triangle is what happens when you apply a s equals -1 distortion to the green triangle. The last thing I want to mention in this video is what happens to the area of shapes when you apply an S-linear translation. You could try and work out a pattern from this example. So you could work out the area of the original green triangle, and then work out the area of the yellow triangle, the pink triangle, and the red triangle, and try and see if there's a pattern you spot. Well, I'll tell you the pattern right now to save you some time. The pattern is quite simple. It just says S-linear distortion scales the area of a figure by s squared. Okay, so that means, for example, if the area of your figure used to be like 3, and you do a 2 linear distortion, then the new area is 3 times 2 squared, which is 3 times 4, which is 12. Okay, and if you were to work this out for this triangle, you'd see that it satisfies this theorem. Okay, so the S-linear distortion scales the area by a factor of s squared. That's the end of this video.